Hi, class. I just wanted to talk to you guys a little bit about heat versus thermal energy and a couple of other things. Heat is the transfer of energy between objects due to a temperature difference. So, my hand was holding on to a cup of ice, and so it's colder, and so now the heat of my hands transferring to the ice, and so now this hand has less heat causing it to be colder. Thermal energy is the total kinetic energy of particles in an object. Um, so, for example, the volume of this pot, you would be calculating the thermal energy for that whole, all of the water in the pot. So that could have a greater thermal energy than like a mug of boiling water because of that volume. So just keep that in mind. You can have greater thermal energy even if they're the same temperature because of the volume of one is bigger than the other. And then heat can cause, obviously, we're heating up the boiling water, can cause the thermal energy to increase, leading to temperature change. So that's kind of the simplistic way of that. And then another thing to remember is the law of conservation of mass and energy. Mass of matter cannot be created or destroyed, and the reactants and products will always be equal. And you might think, like, how is that possible? Like, when I burn a fire, we're left with just a little bit of ashes. A lot of that goes up in smoke, and if you are around a fire, you usually see those little pieces of ash and things go up, and you see a lot of smoke. It's burned into different carcinogens that go up in the air. So the law of conservation of mass just defines that we're not destroying mass, it's just kind of transferring in a way. So you put all the ingredients in, if you weigh them all out, you'll have the same mass at the, or before you bake it. Once you bake it, you'll bake the water out. So don't weigh it after you bake it because some of it evaporated, but prior to. So just remember that. And then law of conservation of energy. I did like the example that they had there. It's just saying that the energy in the system will kind of try to balance out. So if you pour a cold liquid into your coffee, tea, hot chocolate, then it'll get to an equilibrium, kind of balances out the two temperatures. And that's just energy. The cold has less energy, the hot has more, and they balance each other out. So that's your conservation of energy. Trying to go fast, so this isn't too long because it's so hard to not make it longer. These laws are pretty fun. I liked their examples. Charles' law in particular, I thought was a good one that I wanted. That was like, oh yeah, I run into this all the time. Obviously, Boyle's law with flying, I do that too. But you'll notice in the wintertime, since it gets cold here in Idaho, your tire pressure light will often come on. And the reason for that is due to Charles' law, because in the winter, it gets cold, the particles kind of slow down because there's not as much energy because of the cold. And then in the summertime, so then the volume condenses because the temperature goes down. And then as summer comes back, the tires, well, the air in the tires heats up, and those particles get a lot more energy, and it kind of pushes out on those tires a little bit more, creating a little more volume. So when you like fill your tires in the summer and it's just right, and then you get to the winter and your light comes on, you're like, what? Do I have a leak? And oftentimes it's just because of that temperature change causing the volume to have that slight change. So something you'll run into. Next, I wanted to just give you a quick intro of our project. In case you don't watch my longer video, which I do have one totally walking you through the whole project. And it only takes 10 minutes to do the whole thing, and it's worth 30% of your grade. So don't forget to do it. And this is a great one to start on. It's something you guys can understand, and it's easy. And just do it, I promise. It'll be good. And it'll help you remember the concepts. So on the first part, this is essentially your hypothesis. You're just taking what you've learned or what you know and stating what you think the answer is. And then you come down and do the experiment. So on the first one, you're just saying, is it a solid, liquid, or gas for that question? Which has a fixed volume? Oh, I think it's solid. That kind of a thing. And this one, the fourth one's the only one that you have to explain why. Until you get down here. And then you'll do the experiment and find these ones you're just taking screenshots, easy peasy. And then you only have 6 actual questions to respond to. So really not that bad. You can do it, I promise. And a lot of these will refer or testing the things from above. So it's really good. Watch the video if you would like more help, a full walkthrough. Please do that. I don't want you to be afraid of these. They really are students' favorite part of the course because they're fun and interactive. It's like a game. See, you get to click these things and see what happens. You're like, oh, and then you can play with it and see what happens. And so it's fun. I get geek out and it'll make this video way too long. So I'll stop now. And if you guys have any questions, let me know. Bye.